Okay, so here you've got a single phase rectifier feeding into a buck converter. That's right. Just looking at the components and the way they're laid out on the board. So by rights, if we put power on here, I should be able to measure a DC voltage across here.
Yep.
I notice you're not doing any smoothing on the output of your single phase rectifier. That might make a few problems. It will introduce more, shall we say, transients into the circuit. But that's okay. So if we take our input power, put it into here, can you dial up to about, just so put it to about 15 on there? That's fine. So that's 35 volts on the input. So by rights, if I put this, where are we going to go? Between there and there, that should be the output of your rectifier. And sure enough, we've got 30 volts DC. So that's good. And if I was to replace that with the oscilloscope leads, there and there, can you move that dial up? Other way. Keep going. Okay. That is our rectified waveform. It's dancing around a bit because we're not triggering on a channel. Okay, but that's our rectified waveform, so that's good. So the next thing we want to check is making sure that the power from the 555 timer is delivering a pulsed waveform there. How are you energizing your 555 timer?
With a 5 volts.
Okay, so where's that going into it?
Yeah.
Okay, so we need a couple of leads for that. So that's the black one is a positive.
She gone to red. Yep.
Yep. And the black one using the blue wire, nothing like a little bit of colour confusion. As to that there. So by rights now, if we use the oscilloscope, we should see.
So yellow is the output.
Yep. That's it to that there.
Yep.
Okay. Make sure if I. And to the other one is to.
Ground. Should be ground.
To the black one? Is this one here? Can you guys see if you can find anything on that scope there?
Where's this black line?
There is something there. There we are. Okay, if you decrease the magnitude of that so we can see it and wind in the time base. That's as far as it's going. No, wrong one. Next one down, that's trigger level. Across to the left.
Left.
Yep,
Scale.
just under your finger. That's it,
that
scale.
one.
Yep. So, I'm not convinced, because that's on 5 volts of division, I'm not convinced that's your gate signal.
Should be that one. This one and this one.
This one and this one?
Yeah.
Nope.
Something.
This one is short because it's not straight.
I'll just change the lead for some clip leads.
Whatever.
Nothing.
Something is loose.
Getting a trace of something. There it is. So I think your 555 timer is kind of working, but
Oh, there we go.
Yeah, some. Yup. Yeah.
okay. See what it's doing is if I have it there, it is generating a pulse waveform, but it's on for a very short period of time. And when I change your resistor, all it's doing is opening up the period. Okay. So here we are here, that's up there. So that, if we zoom in on that, so it's on for a long period of time, off for a very short period of time. So that's a very high duty cycle. So your 555 timer is not only changing the duty cycle, it's also changing the period, because we go to the other end, and here we are here. There it is there. Okay, and then if I wind it up the other way, so that should work. It's doing something.
Yeah, it is doing something. Yeah.
It's not doing what I talked about in class about just changing the duty cycle. It's changing the period and the duty cycle.
Both are.
Okay, so what we can do is we can disconnect that now. We can hook it up and see if it's going to work.
Not yet.
Just turn it down.
0?
Make it 0.
We'll take our motor, connect our motor to here. Okay. Right. You want to turn it up? Just turn up to say to about 30 or something. Now, what's interesting to note is it is actually working. This here, the yellow line is the voltage being applied to the motor. And you can see with your current duty cycle setting, it is actually turning it on for a very short period of time. Okay, and of course the DC voltage, average DC voltage here is so low, the motor's not spinning. Okay, so if we increase that voltage, dial it up to, what is it now?
30.
Yeah, take it up to about, say, 50. Okay. So we can see our peaks increased. Take it up again a bit more. Okay, so we've got 100, there it is, 150 volts on the input, and that's tiny enough to get it going now. Question is, well, your MOSFET's not getting hot.
Make it also a little fine.
Yeah. Now, looking at that waveform, I don't think you're controlling it all. Okay. That waveform there, first thing I think of when I see that sort of shape output of waveform is that is essentially an uncontrolled rectified waveform with a ripple on it. Okay. So I'd say that your diodes are working. Our output waveform here, we're getting a DC voltage here. I suspect that that's been turned on and is held on constantly. And so that's why, and this is having no effect. Okay. If you look at your waveform coming into your MOSFET. So which is your ground wire? This
Black as ground, yellowed output.
Oh shit. Yeah.
Did you get that?
Yep.
Good stuff.
Might be a bit of jumping, but
Yep.
Should I turn it off?
Yep.
Turn it on. Oh my god.
Okay. So, we've blown your 555 up.
yep.
Okay, blown the pin off that. Okay, we've blown your MOSFET,
What happened?
disintegrated that.
Blew up, bro.
Good.
Yep, she smoked there. So,
Oh, I can smell.
yep, we've got power off, everything's powered off. Okay. As soon as I connected the oscilloscope to it, so we've created an earth path through somewhere. We'll have to have another look at that and see what was going on. That's why we wear safety glasses in the lab. Okay. You can see the discoloring on the track here. It tells me that we are carrying a bit of current through there.
No, actually, we are using the old.
Oh, is this your old board?
Yeah, I
Okay.
know. That's why.
That looks all okay. You've blown some devices. So, if we think back to what was happening before, we saw the ripple there, and as I said, that tells me that your MOSFET wasn't working. Okay, it wasn't switching the circuit properly. I suspect that what happened is as soon as it turned on, it blew your MOSFET and created a short circuit through your MOSFET, and that's why your rectified waveform was going straight through to the output, and your 555 timer wasn't doing any control. Okay? So you go off and have a look at your circuit diagram. We'll come back and revisit that. It'll be interesting to see what the parameters are of your MOSFET and whether there was a reverse diode across the back of it to handle any back EMFs that have been created. We'll go and talk about that soon. Okay?